Gates and valves regulate the flow of water through spillways and outlet works. Gates and valves may be used to control the amount of water leaving the reservoir or to stop the flow altogether. Some gates are held in reserve to be used in emergency situations or for maintenance. This presentation will introduce you to inspection techniques for selected gates, valves, and related mechanical equipment. Detailed data on these features and information on other gates, valves, and mechanical systems are provided in the text. The video will review mechanical equipment and systems and common gate and valve deficiencies, and describe procedures for the inspection of gates and operating systems, and the inspection of valves. Before watching this video, you should have read Units 1 and 2 of the text. As you learned in the text, mechanical devices called hoists and operators are used to open and close gates and valves. Hoists and operators can be powered manually, electrically, or by hydraulic pressure. Electrical and hydraulic operating systems should have auxiliary or emergency backups in case the primary power source fails. Auxiliary power can be provided by engine-driven generators, engine-driven oil pumps, compressed air, or manual systems. The text also discusses the kinds of problems that you should look for when inspecting gates and valves. Cavitation damage is one of the most common problems. Cavitation damage is caused by a combination of high-velocity flows and low pressures. These factors cause shock waves, which result in cavitation damage when the shock waves occur near or against flow surfaces. Both gates and valves can suffer from cavitation damage, as can spillway and outlet works channels and conduits that are exposed to high-velocity flows with offsets and irregularities in the flow path. Galvanic corrosion is another common problem. It occurs when two dissimilar metals that are coupled together come into contact with an electrolyte such as water. Perhaps the most common and obvious problem is water leakage. Leakage through a gate can be caused by several things, such as debris lodged at the bottom of the gate and damaged seats and seals. Oil leakage can be a problem too. Hoists and operators must be checked to see if they're leaking oil. Another thing to look for is surface damage. This includes corrosion, cracks, and loss of protective coatings. Also check for missing, broken, or loose parts, including damaged chains and hoist cables, missing bolts, faulty welds, and broken or cracked structural members. Now that we've reviewed mechanical equipment and systems and common deficiencies associated with them, let's look at typical inspection procedures for gates and their operating systems. The first example is a radial gate with an electric motor-driven hoist. A radial gate can be used to retain water above the control section and to release and regulate water flow. If you are inspecting a gate with water behind it, make sure that the gate has been immobilized. Use red tag and lockout procedures to ensure that the gate won't accidentally be moved during the visual inspection. In this case, the radial gate has been dewatered for the inspection. This inspection will have two parts: a visual inspection of the hoist and gate, and an on-water test operation of the gate. First, conduct a visual inspection of the hoist equipment. Most radial gates have fixed hoists driven by an electric motor. When you're inspecting the hoist, look for condensation in the gearbox and oil sump. Drain any water in the oil sump and record the amount. It's important to do this before the gate is operated so that you can identify the condensation. Otherwise, the action of the gears will mix the water with the oil in the sump and you won't see it. Next, check that all the labels on the control panel are correct. Also look for surface damage and missing, broken, or loose parts. Damage may be caused by vandalism, normal wear, or failure of parts. Check that the reducing gears are properly lubricated. Next, look for other damage, such as corrosion. If hoist cables are used, see that there are at least 2 full wraps of the hoist cable around the drum when the gate is closed. These are called dead wraps. Here is a drum with insufficient wraps of the hoist cable. The cable has pulled through the U-bolt clamp and frayed. Now you're ready to do a visual inspection of the gate itself. Be sure to check the pivot called a trunnion for signs of rust, wear, and inadequate lubrication. If possible, check the area of the anchorage for damage. If any part of the trunnion is badly worn, such as this pin, it must be replaced. Next, examine the structural members on the downstream side of the gate leaf for damage. Most structural damage occurs on the lower third of the leaf because it carries the greatest load. Continue looking at the leaf for broken welds and missing, loose, or damaged bolts. Also check for clogged drain holes in the horizontal members. Open drains prevent ponding of water and subsequent corrosion. Look at the waterway surface on the downstream side of the gate leaf for cavitation damage. Now have the gate raised so that you can inspect the upstream side. The gate should go up smoothly and evenly. Watch for any jerky, erratic movement. Check the bottom seal for cavitation and other damage. Scan the upstream surface area for any broken, missing, corroded, or loose seal fasteners. Badly corroded or broken fasteners should be replaced. Next, check for cracks in the welded plates of the gate leaf. Look for corrosion and rust, especially at the waterline. Also check for cavitation damage on the lower part of the gate leaf, the walls, and the waterway surface, especially in the lower corners. Examine the hitching pin for signs of wear and corrosion. Look at the hoist cables or chains for fraying and wear, especially at the waterline. If a hoist cable or chain is frayed or damaged, it should be replaced. Now test the operation of the gate. With the gate closed, first have operating personnel press the lower button. The motor shouldn't move. If the hoist tries to lower the gate, then there may be a problem with the limit switches. Next, have the gate raised. Look again to see that the gate moves slowly and evenly. As the gate goes up, listen for any unusual noises that indicate problems with the system. If the motors sound like they're straining against the load, or if you hear unusually loud humming or squealing, problems may exist. Another way to tell if there's a problem is by checking the voltage and amperage readings during startup and normal load. If readings are taken at the time of the inspection, compare these with the past readings. A noticeable difference between the past and present readings indicates a problem and merits further investigation. Also, touch the motor. If it's too hot to hold your hand on, then the motor may be overloading. Test the brakes by having operating personnel stop the gate midway up. Leave the gate in this position for about 20 minutes. Then check the gate again to see if it's moved. The gate should stop automatically when it reaches the raised position. Check the limit switches while in the raised position too, by having operating personnel try to open the gate further. If the gate doesn't move, the limit switches are set properly and working. If possible, try also to test operate the gate under maximum reservoir head conditions at a later date. Although there are many other types of gates, you will basically be looking for the same types of deficiencies, and many of the inspection techniques will also be the same. Let's contrast the radial gate inspection with one of a slide gate with a hydraulic operator. As before, the gate has been dewatered for inspection. Slide gates often serve as control devices for outlet works. Slide gates have many moving parts, which can become loose or damaged. As with a radial gate, when inspecting a slide gate, visually examine the operator, in this case, an hydraulic one. Hydraulic operators are usually in protected areas, so surface damage from vandalism is not generally a problem. First, look for condensation in the oil sump. Drain out the water and note the amount. Be sure to check the electrical controls for incorrect labeling, worn wire insulation, dirt, and broken, loose, or missing parts. Examine the pump and fluid lines for leakage. And check that the hydraulic reservoir has enough oil in it. Now check the piston rod or actuator for leakage. Also look to see if the piston rod is scratched or scored. If it is, dirt has probably accumulated in the packing or wipers. Next, look at the gate stem and stem guides for corrosion, missing or loose parts, and scratches. The stem should also be straight and aligned properly with hoist and gate leaf. Now inspect the gate itself. On the downstream side, look for corrosion and structural defects in the gate leaf and frame, especially at the bottom. If the gate is in a conduit, check for cavitation damage downstream of the gate opening. Also, air vents should be checked to make sure they are open. Now have the gate raised so that you can finish your inspection. The gate should go up smoothly and evenly. After the gate has been secured in the open position, inspect the gate guides for damage and warping. Look at the seals and seats for signs of cracking or other damage. On the upstream side, look for damage to the walls and area around the gate opening, especially in the lower corners. Look for debris. Debris can damage the seal and stop the slide gate from sealing properly. Check the upstream surface of the gate leaf for damage. Once you've finished your visual inspection, ask that the gate be lowered and, if possible, re-watered so that it will be under maximum reservoir head for the test operation. When the operator is powered up and after it stabilizes, check the amount of working pressure to see that it's within the specified pressures. Operating pressures can be found in the standard operating procedures or in drawings and manuals for the dam. As the gate begins to rise, look at the operating pressure to ensure that the system isn't using more pressure than usual to raise the gate. Watch for signs of a malfunction, such as binding. Also watch the actuator to see if scratches are revealed as it moves. And listen for unusual noises. After the gate is fully opened, check the pressure relief valve, or pressure switch setting, to make sure the system stops when it should. Instead of a hydraulic operator, you may find a screw-type device run by an electric motor. The rotation of a threaded shaft, which is attached to the gate stem, raises and lowers the gate leaf. When inspecting this type of operator, check for sufficient lubrication and for structural damage, such as bending of the shaft. Now let's look at inspecting valves. The first example is a gate valve with a manual operator located in a small conduit. Although many of the gate and valve problems are the same, valves may sometimes be difficult or impossible to inspect. Some valves are fairly small, and when they are within a conduit that is 30 inches or less in diameter, they are hard to inspect. Gate valves are widely used. They develop many of the same problems that slide gates do. The valve may suffer from cavitation, corrosion, leakage, cracking, and broken or missing parts. If the valve can't be reached for a visual inspection, the only way to tell if it's working properly may be to watch for sticking and roughness when the valve is opened and closed. First, check the operator for any problems. There may be some oil leakage around the stem, but it should be minimal. This gate valve operator is a simple manual system. The important things to check for are missing, broken, or loose parts, surface damage, and adequate lubrication. Now test the operation. Watch for any signs of rough movement or binding. If the valve won't operate, or if the test operation indicates significant problems, the dam owner or operating personnel may have to remove the valve to repair it. Of course, some valves are in large enough conduits so they can be inspected visually. Our second example is a fixed cone valve, also known as a Howell-Bunger valve. The fixed cone valve is opened when the operator moves the cylindrical member away from the fixed cone. Water sprays out around the cone. Check the valve for broken and missing parts, corrosion, and cavitation. This presentation reviewed mechanical equipment and systems and described common deficiencies. It also illustrated the inspection of various devices: a radial gate with a fixed hoist, a slide gate with a hydraulic operator, and a screw-type operator, a gate valve with a manual operator, and a fixed cone valve. At this point, you may wish to review portions of Units 1 and 2 covered by the video. After that, read all of Unit 3 for details on a variety of gates, valves, power systems, hoists and operators, and other equipment. Or read only those portions that apply to the equipment you will be inspecting. Inspection and testing of gates, valves, and mechanical systems is part of an overall dam safety inspection. The information gained from inspecting these components is combined with information from the inspection of other project features for an overall assessment of conditions at the dam. please stop and rewind the tape and turn off the tape player.